Okay, so now we're going to look at classification. All we have done is only one neural network, right? So all we did was just one neuron, right? So this is what we did. Give it X and then it gives us a Y. Just one input, one output, one neuron. Very easy. So the neurons can be, the neural network can be as complex as possible. You can have two with only one output, like two input neurons and then one output neuron, right? You can have different shapes. Now, what you're going to do is classification, right? Now, the classification now depends on the number of items you want to classify. The output will depend on the number of items you want to classify. So, if I want to classify dogs and cats, it means that I'll have what? Two outputs. One for dogs and then one for cats, as you can see here, right? So it means that I will take a picture, I feed it through the network, and then it will tell me whether it's a cat or it's a dog. So in order for it to do that, it will need two outputs, neurons. Have you seen it? One for dog and one for cat. So now this neuron here, these two outputs will give me probabilities, right? So what is the probability that it's a dog? And what is the probability that it's a cat? So the one with the highest probability is the one it chooses. Understood? Right. So you
also want to train it with the data
yeah, of the cat and the dogs, right? So you can give it a cat and it will tell you whether it's a cat or a dog. You can give it a dog and then it will tell you whether it's a cat or dog. Mhm.
So this is about the cat. The cat is giving 0 or 1.
Oh yeah, it doesn't matter. Yes, I'm just trying to explain that. You just give it a yeah. Now here in the classification, right? So now we have you give it the same way. You give it data, images of cat, images of dog, and then you give it a label. So now it depends on how you label it. So if you will say that there are two output neurons, right? So you give it a label of. If I give it a label of 10, right? It means that I'll feed it with the image of the cat, and then I give it the label 10. So anytime it sees a cat, it gives it the label, it attaches to the label 10. So it means that if the first one here is a 1, and then this one is a 0, it means that it's a cat. Then the next label will be a 0, 1, right? If it's a 0, 1 here, it means that it's a dog. Let's say I have a goat more, like something like a goat. So it will be what? The first one will be, let's say, yes, what? So it will be 1, 0, 0, right? And it will go to 0, 1, 0. Then another one, another one, 0, 0, 1. This is how it does it. Hmm?
Let me explain for you so that you write.
Uh,
Yeah, okay, yes, sir. So now we are going to three outputs.
yeah, yeah, yeah. So I mean that so in case we are dealing with two outputs, we only need so now we are using some kind of binary numbers to represent our labels. Binary, just ones and zeros. Right? So if you're dealing with only two, it means that we only need two binary numbers, a one and a zero. Right? So if the first one, I can say, oh, my first label, I'm giving it a cat, and then the cat will be 1, 0. The next label is dog, 0, 1, and then I feed it with images of dog. Then if I say, okay, I want to classify three, cat, dog, and a goat, right? So now, how do I do it? It means that the labels must change. Now, instead of using only two, I use three. So the first one will be the cat will be 1, 0, 0. So three. The dog will be 0, 1, 0. Then the goat will be 0, 0, 1. Understood? All right. This just like this. If I'm classifying numbers, I have a set of numbers I'm classifying 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers I want to classify. So it means that I have a total of what? 10. So my first one if I want to classify zero, it's 1 0 0 0 0. And then if I want to classify a one, it's 0 1. Have you seen it? That's how it follows.
So say, I'm just saying something. So it clearly means that let's say you are giving seven outputs, seven outputs in category.
Mm.
Right? So you have to get the numbers. This should be up to seven.
Yeah, of course. Exactly. I said so for classification, the output equals the number of items you are classifying.
Okay.
Understood?
Yes, sir. So they are 10. The zero is, so they are 10. So 0 to 1 is 10 bits.
Yeah.
But when you watch from zero, select one. From one is even
0, 1, 0, 0, 1, 0, 1. So that's like that.
so the zeros when it starts one, half the first zero becomes you get one zero, two zero, three zero, four zero. You know what I'm saying?
No,
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 no, no.
but when you
It's
look at
like
the table, one itself starts with 1,
if you are
and the rest are
confusing it
0.
yourself, that's what I'm trying to talk about.
No, but if you look at 1, only 0, 1, 1, 0, 1, 0.
Then you start with one.
Yes.
Then you come
But
to two
the
zeros.
zeros are 2.
Yeah, before you count, but when you are counting, you count up to nine. Count about this.
Yes,
It's not
yes.
something.
Yes, you are doing the whole thing. So,
No, you see, what the reason why I'm a little bit skeptical about this is that when it comes to configuration, if you just one word,
Now the point is, you can do it in two ways. You can say, oh, my labels are for zero, I will label it zero. For one, I'll label it one. For two, I'll label it two. For three, I'll label it three, and stuff like that. It's just the same as this one, but here I'm using binary classification. I'm kind of binary classification. This to be one, and then 0 1, stuff like that. So that one, it will depend on you, right? So this is the code to run a model like that. Let me see. I think I've run this code before, right? I think with this and I did some classification. The time I was trying to show you how to use the Google Colab or something like that. Yeah. Yeah. Where is that? Where is this? Now, but let's come here. Let's come here. Yeah. Okay, so let's hurry it up. So this is the code to do classification, and then what I'm trying to do is, I think I ran this, as I said, I ran this the last time, and then I said we were using the MNEST data set, right? I thought that was something like the MNEST data set, and then I said that the MNEST data set contains images of from zero handwritten against from 0 to 1. It look it looks like this: 0 0 0 0, different forms of zeros, 1 1 1, and stuff like that.
different
Yeah.
sizes.
And I said it had 60,000 labeled training images. So we have images for training, and then we have 10,000 labeled validation images, right? So now all you do is for the code, this is how it works. You import the TensorFlow again. The next line of code is data is equals to TensorFlow.keras.dataset. So the TensorFlow itself has the MNES dataset already. So all you have to do is call it, right? So you do TensorFlow.keras.dataset.mnest, and then it will bring out that mnest dataset for you, right? Your next is you take the data here, the one, so it calls the mnest dataset and then it stores it in data. Have you seen it? So after that, if you do the load data function, data will load, and then it will divide it into training images for you, and then validation images. Have you seen it? Training images, then training labels, validation images, and validation labels. Have you seen it? Then the next is The MNES data says it. I think I said the last time that it consists of images which has a width of I think 28 and a depth of what? 28. 28 by 28 image. And then each image stores an 8-bit value. 8-bit value. And then that 8-bit value is called a pixel. Right? So it means that with this 8-bit value, the highest number it can go is 255. The lowest number it can go is 0. So it means that these numbers, the numbers between the images will be between 0 and 255. Right? As easy as that. Now, in machine learning, right, we always want to uh, we always want to we always want our numbers to be between 0 and 1. The machine learns better with zeros and 1, with numbers between 0 and 1, but not huge numbers like the 255 here. So all we can do is we can divide our training images by 255 to bring it down to between 0 and 1, and then we can do the same for our validation data, right? Then our next is the model itself. As you can see, tf.keras.model.sequential. It means that my network is sequential. Then inside it, we have ts.keras.layers. That is the first layer. Then I have something called flatten. And then I have the input shape there. Have you seen it? My next is tf layers.dense. So it means that a dense layer with 20. You see the number 20 there. It means 20 neurons. And then it uses an activation function. I talked about activation function last time. Oh, the activation function here is called ReLU, right? And then the next thing is another dense layer with 10 neurons with activation function sophomore group. Don't worry about the activation function, but the most important thing is that, as I said, I, I can give you a network like this, right? And say, okay, the layers, again, layers into bracket, the type, that is the type of layer. And then I think the next one was what? Output shape. And then the next one was parameters, the number of parameters, right? Understood? So here, how many layers do I have?
The layers are 28.
No, hmm? The layers are not the neurons. I'm not talking about the neurons. The layers.
So we are not getting
How many layers do we have? The first one we did, the first one we did, the first one we did, we had only one layer
one
with only one neuron. How many layers does this one have?
10.
Why 10?
That's TF.
So I said, once I call something like Keras with layers, that is this one layer, this is another layer,
3 layers.
this is another layer. So I have 3 layers, and then each layer has a type. My first layer is layer number. My first layer, the type of my first layer is called flatten.
Okay, the next one is.
The next one is a dense layer. The next one is a what? Another dense layer. So 3 layers, right? Now, what is the output shape of the flattened layer? The dense layer, eh?
For the dense, for the
First one, the first one, the
flattened
flattened.
is 20.
It's 28 by 28. So what we are doing? So you see that my images are in 2 dimensions. 28 by what? 28. So I use a function within. I use a function within a TensorFlow library called flatten, and then it will spread out my volumes. Like it will take this 2-dimensional array and put it in a 1-dimensional array. So that's why we use flatten there. It will flatten. So it takes a 2 by 2 image and then so something like this. If you do it with something like this, so here will be 28 by 28, which is what
Just 7, 8.
784. So here will be something like 9, comma 3. So this is the output shape. Then my dense layer, my second line, dense layer. What is the output size?
That's
Output shape
20.
20, right? To be 9, comma 20. The next one is another dense layer,
That's 10.
10. So we have 9, comma 10. So why is this one even 10? So this flattened layer is the input layer. This dense layer is the hidden layer. This another dense layer is the output layer. Why is the output layer 10? So the 10 means 10 neurons. So why is it 10 neurons? Why is it 10 neurons?
Because the,
Now, even,
the input was, the number, the input was,
now what are we even trying to do?
what are we,
Trying to do in the first place? So we are going to classify some numbers. How many numbers are there?
the, the numbers are 10.
0 to what? 9,
0 to
10.
9.
So that's why the output neuron has to be 10. As I said, each one. And so that's how that's how it will look like. And then the number of parameters, very important. So how many parameters will this one have? Let me just give you this is the input layer. It's just an input layer. It has no parameters. It will be 0. But the dense layer, the number of neurons there are 20. The number of inputs to the so you will have to pay attention here. So the dense layer is 20. So we have this one from 0 to 19 neurons. Let's say 19 neurons. 0 to 19 neurons. All of these are neurons, right? The inputs to them are neurons of from probably 0 to 784 of them. All of these ones are connected. Each one here is connected to all the 20. So if I want to find the number of parameters, the weights, right? The number of parameters will be the weight. I have to first of all find the weight. So the weight here, the weight is equal to 784 times 20 will give me the number of weights. And then I said that each neuron also has a bias, right? So this one has a bias, this one, so it will be the number of will be plus 20. Okay, then what of the last days there? What will be the number of weights?
The weight is still be 784
The
times.
784 fits into this layer, that's all.
Okay, so
This layer also
these
fits.
are outputs.
This layer also fits into the output layer.
So 20 times
10.
plus 10 plus 10.
10. Simple. So give me the number of parameters. Let me see it. So you see how easy that is.
Yeah, but it's a little bit, it's tricky. So, the first one, what is in the bracket?
Which one?
The first column.
This one.
The first column, no, the layers. The first column, the input. What the flatten is, on top of the flatten.
This one.
What's the bracket?
Type.
Right, okay.
The layers, the type of the layer. I think you can stop here.
Okay.
Any questions so far?